Hello everybody, welcome to class, CS202 Online, day 1 of actual material, no longer review. I hope everybody's doing good. Let's go indeed. How do you already guys have all these points? That's a good question. But alright then, well let's jump right into the material. So, today we are going to be covering a couple of things. First of all, we are going to go over function overloading, which will be reviewed if you took CS135 with me in the past. If not, then it might be new material. Either way, it'll get you a little bit of a refresher. We were kind of talking about it last time as well. After that, we're going to get into object-oriented programming, talk about that a little bit, and a little bit about classes, which, again, if you took 135 with me in summer 2, we kind of touched into this already, so this might be a little bit repetitive for you. And yes, so for those of you that are here that are in the class, you will get channel points for watching, and I think you get even more for interacting. I do not know exactly, but the point is that you will get some points. And after you get X amount of points, you can redeem the, it's called something like extra credit attendance points or something, which is about 4,000 points. And then when you redeem that, I will get a notification here on my list of redemptions of things, such as like I got the ones for posture checks and whatnot, so I will go ahead and mark those as complete, and those points will be taken from you. And then what I need though is I need you to message me on Discord who you are on Twitch, because you may not be using your real name on Twitch, so I don't know who to give the points to. So you gotta tell me who that is. You gotta tell me a DM in Discord like, hey, this is me and I redeemed the points. I'll cross-check it with the list, and then you'll get your points. So make sure you do that, because last time around there were some people that would didn't know, and I was like, I don't know who you know, like Tim 567 is when there's nobody called Tim in the class. You know what I'm saying? So yes. But other than that, yes. My extra credit costs 4.4. No, they're all 4.4. It's inflation. They've all gone up to 4.440. I might bring that down a little bit. So maybe today because I need to actually go and update that. It is still left over from. The way it works is I usually inflate it. It starts lower and goes up. So I'll bring it down again. So I guess don't redeem extra credit points yet until which I doubt you'll get today, but don't redeem them today. Okay? If my name on Twitch, if my name is the same on Twitch, do I still need to let you know on Discord? Ideally, yes. That way it makes it faster for me. That would be nice. It's not mission critical if your name matches what's on Canvas. No one matches on Discord because I don't know anything. It doesn't help. I need to know the name on Canvas, right? So yes. Okay. How do you have all these points? Like, I'm so confused. How to find the Discord link? That's if you're enrolled in the class. There is a Discord link. If you're not enrolled in the class, there's no Discord link. So yes, that's on campus if you are. So anyways, let's go ahead and jump right in then, shall we? So let me go ahead and pop open the code. So I went ahead and created just some basic hello world programs, basically just in main, so that we could kind of get going on this. So the first thing I'm going to talk to you about is function overloading. And if you have any questions, just go ahead and post on chat, and I'll try to monitor the chat as well. And we'll go from there, okay? And then I'll try to leave a little bit at the end of class if you guys remind me before the time is up, so we can go over some of the homework questions that you might have from the Twitter assignment. And I went ahead and published the second assignment already, which is related to classes. And you can get going on that if you know classes already from my 135. If not, then maybe at the end of today or tomorrow, you should be good to go on that. So let's go ahead and write a function foo. Or maybe let's make a meaning to this program. So let's write a function that adds two numbers together. Yeah, let's do it. Let's do a function that adds two numbers together and returns the results. It'll print it out in the function, but also return it. How about that? Okay. So we are going to call our function add just together, just because I think add might be some kind of possible word that's used somewhere else, so don't want to cause issues. So we're going to call it add together, and we're going to start out with two integers. We're going to call them int x and int y, and we are passing by value because you don't see the ampersand there, so we'll come back to that later if we want to switch it over, but for now that's good enough. And then I say we want to return something, so let's go ahead and return an integer from that. And that integer is going to be the result of the addition. So we can say return x plus y. We could have also made a temporary variable called sum, like int sum equals x plus 1 and return sum, but this is a lot better, more compressed. So it's better technique, right? We also said that we might want to print it out. So if that's the case, then can we print it out and return one line of code? We probably could, but it would be weird and not intuitive. So I would just make it 2 lines of code. Yeah, because otherwise we'd be doing some weird things that are not nice. So yeah, this will be good enough. Okay, so let's go ahead and test our function to make sure that it works. So let's go ahead and call add together and pass in 2 numbers. So let's try passing in values 5 and 6. And what do we expect to get from that? We expect to get a 11, right? But we'll see if we get it right. 11. Yay, we got it right. So nice. Okay, so moving on, let's go ahead and try to pass in other things to our function. So let's go ahead and try passing in 2 decimals, like that. And then maybe we can also pass in 0 and a -1, just to make sure it works with negatives, which I don't see why it wouldn't, but you know, just variety purposes. So we get 11, right? And we get -1. -1, that makes sense because 0 plus -1 is -1, but 5.9 plus 6.9 isn't exactly 11, although technically it is because we are doing integer addition, right? But then we're like, oh, well, we kind of wanted to have accuracy in this. So what can we do? Well, we could go ahead and switch this to using doubles, you know. But that's only going to fix part of the problem, actually, because we are still returning it as an integer. So while we will get the right number printed out here, if we were to see out what this is returning, ooh, not like that, don't like that. It's not that. Actually, oh no, that was okay, never mind. It is a value returning function. Yeah, so this will be fine. Then we can see that in the function we see out the right value, but we're not seeing the value here because there is a coercion happening on the return value. So then, okay, we got to switch this to a double. Okay, let's try it again. This time we get 0.8. But what if I wanted it to return as an integer? You know, well, I could cast the return value. You know, as I showed you last time, I could do something like static cast int, and then put in that parameter inside, and then we can be basically good to go, right? And by the way, what happens with the 2 integers? What is that going to print out? Is it going to print out 11 or 11.0? I'm not sure. I think 11.0, but let's see. Oh no, it printed 11. So there you go. So anyways, that all works just fine, right? But okay, cool. Suppose that when we pass 2 integers, you know, you wanted it to, instead of just completely, or how about this? Suppose that you wanted it to return an integer directly, okay? Instead of having to cast it. If the parameters here were like a whole number per se. Yeah, let's try doing that. So let's try to actually make a function called the same that is going to sort of mimic the idea of if these were integers, okay? And then return an integer. Now, why does this matter? Well, here's the thing. If we leave this as an integer here, or if we leave it like this, actually, and let's comment this out for a second. You're going to get different computation by doing it this way than it is by casting the parameters. Because here's the thing. 5.9 plus 6.9, that addition together was equal to what? 12.8, right? And then if you cast this down to an integer, you can see you got a 12. However, when these two were integers and you did the addition, you got 11 because you dropped the decimals before the addition. And by dropping them afterwards, it's possible that it goes 1 over, as is happening here. And so suppose that we want to make the concept of dropping the decimals in the scenario where what you guys are all using your your posture checkpoints, but you should be saving for your extra credit points. I don't know. That's the other category. Interesting. I guess it's your points. You can do whatever you want with them. But yeah. So if we want to do something like that, we would need to do the casting before the addition, right? But what if we wanted to have a function that deals with integers and a function that deals with doubles and keeping them separate, okay? Or furthermore, if we want to return a double and one that returns an integer. So for now, let's go ahead and, before we go with the return value, let's stick with the parameters. So we want to have two functions, but in one of them, we wanted to have an integer and the other one that takes doubles. So you could do something like this. And if I go ahead and compile this, you can see that it works just fine, even though both of these functions have the same name. Oh, there's my dog. Hey, little dog. So in this case, this is okay. Oh, what are you doing, dog? I was just turning around. In this case, this is this is okay because even though we have the same return type and we have the same function name, because think about it, when you have variables like normal variables, if I try to go ahead and in the same scope do something like this, int x and then int x again, I get an error, and the error says it's basically redeclaration of something that was previously declared, which we have two of them. The same would happen if I tried to do something like this, void foo, and then I try to do void foo again. Same parameters, same return type, same identifier. And yes, that is indeed path. You can see that you get the same error. Actually, the identical error is just in a function instead of a name. But we don't get that kind of error when we have the same function name, the same return type, but different parameters. And so, yes, that would be basically the signature, indeed. So the signature is your combination of your return type, parameters, and parameters, I believe. And so the thing here is that because you have different parameters here than here, that is perfectly fine as long as you don't have a function. You have two functions that have both the same return type, the same identifier, and the same parameter types. As long as basically one of those things potentially changes, then, well, not one of them, because the return type is kind of special. See, if I try to do here this, that goes fine, but if I just try to do something like this, that is going to cause problems because then it's not going to know which one to call. We're going to have an ambiguous declaration. So you can have the same return type, same function name, different parameters. That's okay. You can, of course, have different same parameters, same return type, but different name. That's perfectly fine. That's like saying void foo and void bar. But if you have same parameters and same name, the same return type is going to cause conflict because it doesn't know which one to call. And that's what really this is going to resolve to. This issue, well, not an issue, but risky feature of having the ability to have the same function name with different parameters is meant to allow flexibility in your code. So in our case, when we have an add together function that works for both double and ints, but in their own unique way, that is okay as long as it's never ambiguous which one I call. So let me tell you when that would be a problem. And let's just make this, well, be an integer as well, just so that they're as close as possible together. Okay? And so this is okay. This compiles because it's very clear to the compiler that this function call to add together is going to go to this one because the parameters are integers. On the other hand, this function call is very clear that it's going to go to this parameter, this function, because the two parameters are doubles. In fact, you know, I can even put something like doubles here, and then I can do the same thing with the other one, but say integers, so that you can kind of see which one's getting called. You can see integers gets called for that one, doubles gets called for that one. Oh, and we have a third one that's just integers. So no problem there. However, that doesn't mean that this code is always going to be okay, because suppose that I try to do a function call that says add together, and then I pass in perhaps a float, or perhaps I pass in, well, a float is actually, yeah, float I think will be okay. It's the other way around when things cause problems from double to float. So if I pass in a float, I think I should be okay. If I remember when we were doing this a couple of days ago, I think that one is okay. Yeah, because that one, it says, okay, these are decimals. Doubles have more accuracy than floats for the most part. So we'll just make them floats, no problem at all. This guy meant to use decimals, so we're using this function. You will see that the opposite will not work in a second. But suppose that we went ahead and threw in one float, or one double, and then one integer. This is going to cause problems. Because, okay, if we try to call this one, you know, this is a double, and this is a double, so no problem there. You know, that matches. This one is an integer, and this one is a double. That is potentially a problem, but not necessarily. If we only had one function here, so if I went ahead and comment this out, this would compile and run just fine. So it's only a problem when I have two functions, the two functions here. In fact, I could do the opposite. I could go ahead and then comment out the top one, and yet again, this runs just fine. Pending that that's what you want to do actually with the code. But what I'm saying is that it compiles okay. It doesn't compile when we have both of them, even though it was compiling with these ones. The problem is that this can resolve to a double, but to resolve this 5 into this function, it needs to be coerced into a double. So you could think of that as a distance of 1. It has between your call and the formal parameters, between the actual parameters and the formal parameters, there's a distance of 1. Okay? On the other function, if we try to use that one as a reference, then we can say that this integer matches this, so that's a distance of 0. But then we have the same issue but backwards. Now we want to convert a double into an integer, and in this case, that would be considered a distance of 1 as well. So basically, we have no function that matches our parameters exactly, and the two options that we have a distance of 1 means that we can't know which one to pick. If we can resolve to having a specific distance to a function that's unique and the smallest possible, then it works. So I'll show you when we come up with a more complicated example. But in this case, this is why this is confusing, saying, okay, who do I call? If I go with this one, I got to do one coercion. If I go with this one, I got to do one coercion. Both of them require one coercion. There's no functions that require 0 coercion, and so that's why it's confused. It's like which one is the one that you're referring to? You can, of course, avoid that issue by casting. You could cast one of these potentially by saying static cast double, or you could do the opposite and cast that one to the other one to an integer, and then you're okay because you've removed the ambiguity of the problem. But otherwise, the compiler's like, I have no idea which one you want to call. They're both the same distance away. So, what would be other examples of such a situation? Well, welcome. Suppose that you had, I'm just gonna use letters to represent the parameter types. So suppose that we have a float, and we have an integer, and we have a double. Okay, so we have 3 parameters in our function f, and this is the function call to it. Now, which options do we have? We could have an f that has I for integer, so we have 3 integers there. We could have an f that takes 3 doubles. We could have an f that takes 3 floats. And then we could also have, I guess don't get confused between the f and f. We'll make this uppercase f, that way they're different. We could also have one that takes integer, double, integer. And that's good. And they will all compile. You can make all of these different functions and they will compile. The problem isn't with the function themselves. The problem is with the function calls. So I actually don't even know which one is going to resolve to. So we're going to have to zoom in a little bit so we can see them all. So let's see. Let's see if we try to use the first one. How many coercions do we have to do? Well, the integer and integer are fine, but float to integer is 1, and then double to integer is 1. So this one requires 2 coercions. Okay, what about the second one? The second one, this is okay, but this one and this one require 2. So 1 plus 1, 2. So far, you know, this is kind of bad, because already, like, if we don't have anything better than 2 for the rest of these, we're going to have a problem. But we don't know that yet, so we'll cross our fingers here. Okay, for the third one here, we have the float that matches, so that one is okay. And then we have this one that goes to an integer, so that one is going to be 1 coercion. And then the float to double one, that one is kind of special. I would say that's like 0.5 of a coercion per se, in the sense that you can kind of think of that as like not really necessary of a coercion, but kind of a coercion. You saw that before. It actually helps out. Like if it's stuck between casting this f to an integer. So if we had something like fff and then we had ffi, then for sure. Or sorry, if we had oh, no, because actually we're going from double to integer here. Never mind. I thought we were going from float to double, but we're going from float to integer. So actually, I did these backwards. Let me make sure that I didn't mess up any other ones. So, yeah. Okay, so my bad. I was looking at them backwards. So this is the function call, and these are the function parameters. Parameters, call. So because of that, the first one is going to still be 2, but the second one is where that issue happens. The double, that one matches. The integer to double, that one you can consider plus 1. But the float to double, that's the one that actually I'm talking about. So this is the one that's kind of like a 0.5-ish actually. You know, because, so it's more like a 1.5 here really. Because that one is kind of okay. Like, it's like, you know, it is coercion, but it's not so bad because we don't lose any precision. So while I would prefer an exact match, so I would prefer a parameter that's a float, you know, I'll take double over integer any day. So like, it will prefer that one. The issue comes with the third one, where float to float matches, integer to float, that is definitely 1, even though there's no accuracy loss per se, or yeah, technically there might be, but there, you know, it's not as bad. But double to float, that's kind of bad. In fact, I do believe languages like Java don't let you do that coercion, like double to float, because you lose precision there, because you can store more accuracy in the double. The Mantis is bigger, I think. So the last one we got integer, so we got float to integer, that's bad, 1. And then we have, so this one was 2 by the way. And then we have integer to double, that's, I mean, it's no loss of accuracy, but it goes up. And then double to integer goes bad. So I think in theory, it's gonna pick this one, but we can test it. We can code it. From double to float, is the double just truncated? So in C++, they allow you to do that. And so yes, you will just lose the additional precision. So in other words, it will let you do it. It will compile. It will work just fine. But it's bad because you lose precision. And so some languages like Java do not even allow it. So I know that because Peterson always was like, how is this allowed in C++? And made a big fuss about it. So let's go ahead and test this. So we're going to call this void f, capital F we said. And then we have int A, int B, and int C. Let me switch over to the, there we go. Int C. Doesn't really need any body. In fact, just to save space, we're gonna do it like that. And then, no, we don't need semicolons actually, but maybe we might. I don't think we need a semicolon inside of that. Yeah, we don't. Okay, cool. And then for the rest of the functions, we have double, double, double. So double A, double B, double C. Java only allows widening coercion, right? Yes, that's what's called widening coercion. So basically, it only allows you to not lose precision by going up in accuracy, not down. So that's why going from double to float cuts up the precision, and basically Java is like, no, you're losing accuracy. This is a bad idea. So, yep. Float A, float B, and float C. And then we got Oh, there's 4 of them. This is all floats. No, yeah, okay, so integer A, integer B, and no, there's a double in the middle, so this is double B and integer C. I don't think I have typos, but we'll find out. Oh, no typos. Okay. So now we have F, and we are calling it on a float, an integer, and a double. So 4.5F, that means it's a float. 5, because that's an integer, and then the double would just be like a decimal, so 4.3. And the question is, will it compile, and which one is going to pick? And I think that is going to pick this one, to the point that I'm going to put a cout statement saying this one. That way we know if it actually worked. So step 1 will be, will it compile? Step 2, which one is going to print? So we'll find out. And it says it's ambiguous, so it actually complained that it's ambiguous. It basically did not like the fact that us going from float to double, again, that's not a lot, that's not loss of precision. And then going from integer to double is not loss of precision, but it's a distance of 1 per se. And then this is a match, an exact match. So interesting. So it actually had, so let's see which of the ones it didn't like. It doesn't really tell you, it just tells you that all the candidates are there. So which of these would we have to get rid of? Let's try to get rid of the integer one and see if that would work. Doesn't like that one either. Do we have anything else that is distance of 2? We have all the float ones, so we'd have to get rid of all of the float ones. So basically, okay, so it's essentially thinking that all 3 of these have a distance of 2. So in this specific case, it is saying that the float, integer, double is as far away as the other 2. So all 3 of these have the same distance to this guy. So interesting that it did that. So whereas in Java, it would have discarded this one as an option because of the loss of precision, and basically this one probably would have complained as well because of the loss. But I don't know, we're gonna work it. But anyways, how can we fix that? Well, if we turn, let's try turning. I think if we turn this one into a double, then I think we should be okay. No, we're not. Why? Double in double. So we got double and double in integer. So there's a distance of 1. Why is this one not okay? Let's see. So we got a double here and a double here. So this is really only a distance of 1 in my opinion. But I think is it conflicting with this one? Let's see. No, it's not conflicting with that one, or at least. And then this one is 1 integer away, so it's possible it might be because of that one. Yeah, so actually, this one apparently, even though this would be technically, I would say this is its conversion of 2 because this integer has to go to double, and this integer, well, this double has to go to integer, double to integer, and integer matches. So this is, I would say, a distance of 2 away, and this one seems to match by 1. It's still confusing at that. So there you go. So maybe there's more to it than just a simple distance of computation. So anyways, the moral of the story from all of this is that you don't want to have all these mesh, all these sort of guesstimating of how to do things. So you have two options to this. One of them is, do you really need both functions to be the same name? And if that is the case, then can you make it clear enough in your documentation so that the users of your functions can, call the right function, or at least do casting if they can't handle it? Because that's the easiest solution to this problem is just to cast things by hand to the exact signature that you're trying to go for. That's, I would say, the best solution. While I'm at it, something that I did talk about in 135, but you may not have heard in your own 135, is the concept of default parameters. And that's another kind of useful thing that kind of goes into this idea of same function name but different number of parameters. So let's take a moment to talk about that. So for now, let's comment this one out. And so what are default parameters? Well, think about getLine, because you guys are using getLine in your assignment, right? So getLine allows you, and I believe, yeah, here we go. getLine allows you to read in input from the user with a couple of parameters that you have to pass in, and some of them that are kind of optional. So the first thing you're going to pass into getLine is what you're reading from, the IS stream that you're reading from. This could be a file, or it could be just the CN, the standard input. So let's say we're reading from CN. The second thing is where you're going to store what you're reading in. So that's typically some sort of string. So, you know, if we were to make a string here, str, then you could pass in str there. And you could call it a day there and you're done, and then it's just going to read in. But how is it going to read in this case? Well, it'll read in until it finds the first line feed. So /n per se in your file. At that point, it'll stop reading. But getLine can also stop at a specific character that you define to be the case. So suppose that we want to stop reading at a comma like in the assignment. What do? You pass in a third parameter that it can take that is, you could say, optional. And that parameter is going to be the character that is going to be called the delimiter. And so in this case, you know, we want to stop when it reads a comma. So by putting a comma there, now getLine is going to have a different functionality. Instead of reading it into the line feed, it'll stop reading onto the comma, which is how you want to read your CSV files, because that's kind of essentially what they are. And an easier version of that, actually. So, yeah, functions like getLine, one way to do this could be to do function overloading. The other way that you can do it is with default parameters. And so this is an example of a default parameter. So suppose that we were trying to mimic the functionality of getLine. So getLine probably returns some kind of error state if it fails. Might tell me here. SS size t. So return size t. I guess the size of the number of characters read, if I was to guess. We can always go to the documentation and refresh that. But anyways, since we're trying to mimic it, we're gonna call it ghetto line, like that. Get line, ghetto line. So okay. It's going to return size t, which I guess in our case is just going to be an integer, which is the characters read. The first parameter is going to be the IS stream. So that would be, if I remember correctly, IS stream. Is that what it's called? OS stream, IS stream. I think there's just one S. Yeah, there we go. And then that's going to be sort of for fake CN, which we'll call in. And then the second parameter is going to be the string, like again, where you're reading in. Although that one is being passed by reference because it's going to be updating it. And by the way, the reason why you pass in, I think you have to pass in the IS stream as by reference, actually. If you pass it by value, it'll give you an error. FYI, when you're working with file streams, that's actually a thing. So we'll call it str. And then the third thing, which is the parameter that we want to potentially be the line feed or the character delimiter. So one thing we could do is we could just write, you know, char x and then write our entire function, and then we could make a secondary function and then that one not have the parameter, right? We could do something like that. And then just for now, return. Actually, it'll compile, I think, without the return 0. It's just bad. It might give you a warning if you do something like, what is it, -wall? Yeah, see, there will give you a warning if you do. -wall is a good compile flag to check for some errors that would otherwise go unseen. But technically, they're not errors, you know, because if a tree falls in the forest and no one is there to hear it, did it make a sound kind of thing? So it's like, it's okay, you know. So, but yeah, when you're compiling, it might be a good idea before you submit an assignment to run it with the -wall command. There's also pedantic. I think actually that might be is that a C thing? It might be a C thing. I don't know. It's been a while since I used that pedantic flag. Whatever. I don't check for errors. If it compiles, it must work, right? So yeah, that's my logic when I'm making your assignment, guys. That's why I think in assignment 1, the count for the Twitters is off by 1. So FYI, that was the thing in the Discord we were talking about. I think mine has a bug because I count the line feed at the end or something. So if you're up by 1 there, don't panic. But anyways, back to this. This is one way to do this, right? But then you got to copy and paste most of the code, and you know, we want to be smart about the coding. So the other way that you can do this is with what's known as a default parameter. Default parameters allow you to have parameters that are sort of optional. And if the user doesn't pass it in, then you pass in a sort of a default value. And the way that you do that is you put your return type, you put the identifier, or not the, sorry, the data, you put the data type, you put the identifier, so car X, and then you assign the value that's the default value in the case that the user doesn't pass anything. So in our case, it's going to be the line feed character. So that would be our get to line. How this will work is if I call my geto line like this, get to line, and I don't need to return anywhere. I mean, unless I want to handle the get line return statement, which we never do, to be honest, unless you're error checking. We will when we get to exception handling maybe or something. But then I could pass in cin, I could pass in my str again, and I could just run it like that actually. And then this will work just fine. I mean, obviously I don't have something to cin from. But the other thing I could do is I could do get line. Oops. With a parameter, which could be the delimiter. Like that. And that one I can probably show you on the terminal, because I can comma separate something. So here, let's run it. And then, oh, well, I don't have code in here yet. Let's put in some code in here. So in str. That's not really how that works, to be honest. We actually need to go to the delimiter. So how would we do this? We'd have to read in, oh, that's a pain. We have to read in character by character into a temporary car and then concatenate. Oh, okay, we'll do it, whatever. Car temp, and then for, oh, how much do we read? Let's make our code safe by having a limited amount. I is less than 256. Let's go with that. I plus plus. Obviously, this is like where you make your code safe by not reading in forever, because bad things can happen. Okay, and then from there we're gonna make a string. Well, no, we have the string str, but we're gonna clean it up in case there's something in it by putting things like that. And then let's go ahead and do str equals. I hope concatenation works with the character temp. Yeah, hopefully that works. And then how much? When do we stop reading? We basically want to have an if statement that says if temp equals to the delimiter, which is x, then breakout. You know, better way of coding this would probably with a while loop, but I like the for loop because we can stop it as sort of a max amount of characters read before you actually just give up. So you don't get an infinite amount of characters fed in, which might overflow your system and create a security vulnerability. So the only thing left here is to go ahead and read in. So C or just in TMP, and I think that's good enough. I don't know. That was fun coding on the spot, right? Okay, so let's try it. Hello, comma, world, comma, LOL. And it should just read the hello part. Ah, it's still looping, I think. So I think we failed. Oh, no, we have two getter lines. That's right. Oh, shoot. The first one is gonna... No, but then the first one should have also stopped at the comma. I don't know. Let's try reading it again. Nope. I think we're just... we're looping forever here. If temp equal x. Let's see how we're reading in and see if it what is happening. See out temp. See out debugging, guys. Hello, comma, world, comma. Hello, comma, world. So it's not stopping at the comma. Why? Oh, because I have it set at the line feed and it's never going to get the line feed from this. So, no, they're not fighting. What's happening is getLine is not very friendly when you're using actual input from the screen. It's better when you're reading it from a file. I'll show you that it works. But for now, let's comment out this one, and then the other one should be okay. Hello, comma, world. There we go. So as you can see, hello, and then comma, and then stop reading. And if I was to actually see out the string here, you would see that it worked just like getLine would. Blah, 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 comma, blah, 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 blah. And it stopped reading at the comma, and it put in everything before the comma. Including the comma, though. Dang, why did it put the comma as well? I didn't want it to actually put the comma in there, technically. That is one flaw. If temp is equal to, it says break. Why did it put in the comma in there? what did you change to fix this again? It wasn't broken. It was just a get line is not very useful. It's not very friendly when you're reading in from the terminal manually. It's nice when you're doing like Linux redirection or file streams. So it wasn't that it was broken necessarily. But it's still reading the comma right now. So I think we need to figure out. Okay, so let's see. Cout temp. If temp is equal to the comma, break. Oh, I see why. Right here. This should be before. Right there, like that. Because see what's happening. It checks the previous thing that it read. In fact, that's kind of dangerous because at the beginning we were checking garbage, whatever it was in CN when you passed it in. So that was a bug. Now we should be okay. Let's get rid of the cout because that's kind of annoying to see. But there we go. Hello. So there we go. We just mimicked the functionality of getLine. What is in? Is that the same as CN? Yes and no. So ISStream is a class that handles input per se streams, and one of the usage of it is the regular standard input ISStream, which is your CN. That's how CN works internally. If you try to pass CN to a function, this is the data type and form that you have to pass it in as. It also works for file streams. So if I was opening a file, then I could also use ISStream and it would work for that. Although I could also just use fstream if you include that class. So ISStream is just a type of variable that CN actually is. Maybe nobody ever told you in like 135, like you never wondered yourself like, what kind of variable is CN? Is it a string? Is it an integer? Is it a struct? What is it? The fact of the matter is that it is actually what is known as an ISStream variable, which is a class. And when we get to clauses later in the day, that'll make a little bit more sense. But you can think of it like a struct. I know for sure you guys cover structs. So you can think of it like a little struct. So that's what ISStream is. So if you ever want to pass, the most common usage of this and what you might do in the assignment is if you open up a file. If you open up a file and you want to pass in the file stream variable into a function so that it can keep reading from your file, you need to pass in an fstream. But you could also pass in an ISStream. And the advantage of ISStream is that it works for both file streams and standard input, whereas fstream only works for fstreams. I actually have code on Canvas that I had open and I was going to go over, so it might be a good time to kind of segue into that for using file streams. Oh, that actually worked out. That looks nice. So might as well do that. That's a quick review. I can't scroll down. Now I can. Okay. You're just missing the closing curly bracket, but you're fine. So when you do fstreams, you have to include fstream here. And by the way, that's why this is called IOStream, because this is ISStream and output stream. If you wanted to do cout in the code here, all you have to change is the I to an O. And now you can do any sort of output streams, like cout or an fstream that is going outwards. So from here, important thing would be this is you declaring an ISStream variable that you can use to open up a file, just like you could declare like an alias for CN technically. This is you declaring an outwards variable, so ISStream, so that one's for writing. Refresher, how to open up a file, you use the .open, so this is member access operator open, and you pass in the name of the file, and then you can work with it. The name of the file has to be a C string if you're compiling with C++ 98 or 2001. This is something I learned last semester from Dolly. Apparently in C++ 11 or later, you don't have to convert it into a C string. It'll open any kind of string. But if you're working or you're trying to be backwards compatible, how do you turn a string into a C string? Quite simple. I actually have another thing on Canvas for that. Oh, that was just a link. But basically, all you got to do is this line of code. The string that you're working with, so let's say this is my string, file.txt, and you put .c_str, and that will convert it into a C string, which is essentially just constant characters. It's a const, array of const, a const car array per se. That's essentially what that is doing. But anyways. Could we compile with this, or do you prefer C98? Oh no, you can compile with C++ 11. In fact, Sally by default has C++ 11, and I recommend that you always use modern tools, not necessarily. I mean, if people want to use something from C++17, as long as it's not something to avoid doing work, like that's more of a data structure kind of thing. But for 202 and 135, I mean, if they want to use, for example, toString, which is a function that's only available in C++11 or later, which is a function to convert an integer to a string, which is something that is actually quite useful, unless you do a string stream, which is an alternative for that. But if you just want to convert it immediately, that is only available in C++11. So I encourage people to learn that, because then they can learn a couple of the modern features of C++11 and on, like for range for loops. So definitely I recommend that you guys use those. Now, I do warn you, even though Sally compiles by default with 11, if you submit an assignment that is going to be that is necessary to compile in C++11 or later, do put it in your comments that any sort of flags that they need, including the version of C++. That way the TA just knows, in the case that he's intentionally putting like an older edition or something. So, you know, I like teaching this class so much more than 219. It's so much more fun. But don't tell the 219 people. But yeah, okay. So if you want to read into the file at this point, you can just use the insertion and well, in this case, it's the extraction operator. That's the one with the two less than signs, I suppose. And then the other one, which is like your cout, that is called the stream insertion operator. The names, I tend to get them backwards, because insertion is putting into the terminal per se, and extraction is extracting from the terminal. But if you think about it in terms of variables, it's backwards. So iffy, but that's okay. That's a 135 thing. You guys are not gonna get a question on the name of variables anymore. That's 135 land. Finally, if you want to close a file, you should close files, especially if they're files that you're reading in. But I do believe for writing files, it's a good idea as well. But I even commented it out because I said it's not necessary per se. But for reading in, it's a really, really good practice. Otherwise, that's technically, I believe, a memory leak as well. Or a file handle that's lost. So yeah, close your files. Be a good programmer. So anyways, quick flashback review of that, which should help you with the assignments. So back to this. We're breaking our getter line, and we created this sort of default parameter. And so this syntax is very cool, and it allows you to have optional parameters in the sense that this first getter line will just use line feed as a default. Now, how can I prove you that? Because you know, it's not really working with the terminal. I can just make a file, hello, world. No, not even spaces, so you can see. How are you? Is that code you showed us on Web Campus? Yes, it is. It is on Web Campus. Even like, if I will scroll up, you could see it's under. If you click on home, each topic has a bunch of extra stuff like this one, and these are the two that I just showed you. There's also a practice quiz I posted. It's just a question, and then there's a link to the solution. Obviously, don't click on the solution. Do the thing first. It's a good refresher. Although this one is extremely easy. It's more of a practice, and then you can see the solution. This is something that you should, like, I even put here, like, you gotta retake 135. You can't do this one. So you like feel bad if you can't get this right. Make sure you get it right. But yeah, it's a good practice, and also gives you an idea of how my exams are going to be like, the kind of questions you might expect. So, but yes, all the code that you see from Canvas is, when I'm showing you Canvas stuff, is here. This is code that I wrote actually during the lectures in the, when I did this in the fall. So these were done live. So because of that, sometimes they're not the prettiest looking of code. Obviously, I'm not doing them live now because that would take time, and it's summer, so we're trying to save time. So like, this is something that I actually spent like an entire class on or something. And in this case, when we get to this, I might just like show it to you. And then the time it takes for me to type is time that we save to explain things better, right? Although there is a merit in typing things out. So I think for regular semesters, coding on the spot is a very good thing to do. So I love doing it. And even when I have errors and they get stuck for a minute, it's good, because even that troubleshooting is something good for people to see, because they learn from it too. You know, you're never going to code perfect code. It's fact of life. And because of that, it's good to know how to solve problems when you face them. So it's a good thing to see as well, to see somebody else go into that troubleshooting. I've done it already probably today. I mean, it's just like, it just happens. Anyways, we created a file. Now we can go ahead and use Linux Redirection. So let's get rid of this pedantic thing. It's kind of annoying. How do we use Linux Redirection? The little less than or greater than sign. If we do it this way, it is for input. So then we can feed in a file, and basically that file is going to replace us typing in the terminal. Basically, it's how a TA would want to grade your test, because, or the homeworks, because then they don't have to manually type in all the entries. It's just pre-typed, and it feeds it in as it comes. On the other hand, if I use this one, that one is for output. So I could make a kind of like an output.txt, and then it'll write to that file whatever it would have written to the terminal, and the terminal will not have anything. In my case, though, we're not going to use that one, just the input. And then, as you can see, it actually read it into the hello. The well, we got to print it twice so you can see it again. How about we, yeah, no, okay, sure. Yeah, we can do this actually. And then, so you can see here that, what is in the file? I forgot. That does not look right. I think we went out of bounds there. No, we got hello. Oh, I see, because there's only one line. And the first thing is separating by line. So line 1. Okay, there we go. So now we got multiple lines in the file. And so now the first ghetto line should read that line 1. And the second one should read the word hello. It is skipping it. Oh, I know why. Because, well, okay, maybe I'll ask you guys. Maybe you'll know. Why is this failing to detect the line feed? It's something that they told you in 135 about CN and using the insertion and extraction operators. Any guesses as to what it is? I can even do a poll. Well, we run a, no, because it's kind of hard to do a poll without giving away the answer completely. So we'll wait a couple of 5, 4, 3, 2, 1. No guesses. Okay. The problem why is because CN and Cout, specifically CN, when you're reading into a variable, no, that's not actually why. When you're reading into a variable with these extraction operator. See, I'm getting the mix now. It's the extraction operator. That is what is known as white space insensitive, meaning that it skips white space, and that includes spaces and line feeds. So I'm never going to be able to read a line feed using the extraction operator. That is why it just eats my line feeds and just goes on forever. So for that, I need to use something else. So what can I use to read a single character? There's a function called getChar, I think, that I can probably use. Also, I think there's cn.get, but I think that might have the same issue. Let's try cn.get. What does that return? That is an integer. That does not look right. Oh, no, there we go. And that's a buffer. Car. Okay, let's just try putting in a car in there. Temp. Let's see if that would work, but I don't know if that's also going to skip it out. No, that worked. Perfect. Okay, cool. So cn.get will not skip the white spaces, which are spaces, tabs, or line feeds. The extraction operator will skip the white spaces. And so there we go. Now we fixed our program. We might even be able to get it to run on the terminal here. So if we type in like blah, 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 enter, and then that echoes that. And then we can do blah, 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 comma, and it echoes a hello. So there we go. So even works in the terminal now. Cool. So we can remove the text file. So I guess we learned a little bit more about other ways of reading an input. We can use get to reading characters and not ignore white space. So whenever you have a problem like I did, where you actually want to read in the line feeds, you can read character by using cn get. Or you can use get car, get ch, but then you got to use the ncurses library, and you got to use a different way of reading in, or actually not even couting at that point. So we might do that actually for one of the assignments. That will be the continuation of the Battle Royale series of assignments. But okay, I think that is enough to talk about default parameters and all that stuff. However, are there any questions on how to use that? There is, I guess, one last thing that I want to mention about it. Default parameters have to go as the last parameter in your function parameter list. Why? Because if I go ahead and try to make, for example, this one into a default parameter by putting an equal here, it means that it may or may not be included in some of the function calls, right? But at that point, it becomes ambiguous when it's actually referring to this parameter and when it's not. So all your optional parameters have to go at the end of the require parameters per se. So you have to have all the require ones first and then your default ones at the end. Otherwise, it doesn't know. Also, if you have more than one default parameter at the end, then if you pass in an extra parameter, it's just going to try to fit it into the first spot available. And so if you need to feed it into the second one, then you have to pass something into the first one. Otherwise, it can't just skip them. So that is more of a design problem than a C++ thing, actually. So, okay. I don't see anybody else saying anything, so now we can hop over to the next one. And you see me saving all these pieces of code. I do save them into a folder. Last time, before the test, I went ahead and posted this on Discord. And I'll probably do that if you guys remind me before like the midterm. Because last time I did it before the final, but like I could do it before the midterm. And then you can have all these sort of code snippets that are pretty useful for refreshing the material if you're rewatching the lecture and so on. You can also just copy and paste from the lecture, but then you have to type it in, I suppose, if it's a screenshot. So anyways, classes. Now we finally get to a little bit of interesting stuff. So for that, let's switch over to the Twitch chat. See, my dog is right here, and she's like a heat generator. So I'm like sweating because the heat from the dog is coming to me. Works great in the winter, but in the summer it's not fun, even with the AC on. So I'm like sweating here. Okay. So, but I can't kick her out. That'd be mean. So, okay. So, again, this will be reviewed for the people that took 135 with me. So bear with me here. But let me give you the same spiel that I gave them. So far in 135 land, oh, there she is. In 135 land, you learned that one of the ways that you can save work is by using functions. And how you interact with functions is you have function parameters to send data. Oh yes, please go. Yes. Yay, she's left. Okay. So, oh man, this is warm. So one of the ways is you can have function parameters to feed in data to your function. So if we have a function, actually not void, but in this case, let's say it's string. And then it takes a parameter x. Okay, so let's say we have the following function prototype. And remember, function prototype is going to be something like this, where you just basically declare your function. Then there's also the function declaration or body. That's where you're actually putting the curly brackets, right? So if we have the following function prototype, this function takes in the one value, passing by value, so it must be just an input parameter. And then it has a return value here, right? Now, what if you happen to have multiple input parameters? That's okay. You can list as many as you want here with commas and so on. However, what if you want to have more than one output parameter? Well, you're kind of limited into a couple of options. Option one is you could pass by reference. So you could actually use the same parameters that you're using to pass in data to actually pass out data. And you could do this for as many parameters as you want within the limit of the architecture of the system. And the other method that you could do is you could probably use a struct, right? You could create a struct, struct A, and then you could list all the parameters that you want in there. for returning. And then you could just go ahead and make this be of that struct type. And so now you can return as much as you want, right? So that solves part of the problem. I mean, you can kind of do the same thing for the input parameters. You could put them on in some big struct and then pass it in. So that sort of idea is what led into the concept of object-oriented programming, because they said, okay, we cannot return more than one thing, and some languages do allow you to return multiple things, but not in C++. And they said, we could put things in structs, but can we go further than that? Can we store more than just variables and structs? And the answer is yes. You can store both functions and variables. But why? What is the purpose of doing that? Okay, so now it comes in my bucket example. So normally when you're working with data, there's two sort of big things that you're going to do. You're going to have data, and then you're going to have operations that you perform on that data. Those operations may be processing the information, maybe reading information more into the computer, so more data, getting more data, and returning data to the user. So you have I/O, input and output, and then you have potentially processing that is happening in there. And you might also need to store things temporarily as well, storage, while you process them further out more, okay? You might need to, for example, just like the assignment actually, read in the Twitter data, process it, and then store it in a file, because you have to. One of the parts of the assignment is you're storing in all the tweets in the text file as output, right, in a different format. And so it would make sense, since everything is related to the same data, and you can say that your data is all your tweets. It would make sense to kind of group things together or encapsulate them together, and then put them in a little bucket. Because now my little bucket, that looks more like a straw, could have a little handle, and it's a lot, or now it's a cup, I guess. You could carry it and move it around with you and pass it into anything that you want. And so that is sort of the idea behind an object, okay? So these objects are going to be made up of a class. You could think of the class as the blueprint and the object as an instance of that blueprint. So an instance of a class. And so this bucket can hold data and also the operations that belong with that data. Why? Okay, suppose that you are making a class that can hold a rectangle, okay? What can a rectangle have? What data does it have? What properties does it have? It has a length and a width, right? So you have a length and you have a width with a rectangle. And they could be doubles if you want more accuracy, but we're just saying they're integers, right? Okay, these are just integers. They're relatively meaningless until you say, oh, well, L is length and W is width. Okay, so you then go ahead and create a function called area. And that function is going to compute, surprise, surprise, the area of your rectangle. So it requires to have basically both parameters. Now inside of this function, you need to do the computation and then return it. So I guess in that case, I love writing Boyd. you make it return an integer, okay? But here's the thing. This function is completely useless to non-rectangles. Because if you have data that's a triangle, that's a completely different formula, right? Well, not completely, but it's not the same formula, right? What's the area of a triangle? The area of a triangle is length times width divided by 2, right? If you go even more quote-unquote complicated, you can go to a circle. A circle, what is the area of a circle? Pi r squared. So it requires one parameter actually, and then a constant. So it's unnecessary to create a function in the global scope, which is how all your functions you've been doing so far are created, when it's only useful for a specific part of the program. It makes sense that if you're dealing with rectangles, you have access to the functions that deal with rectangles and not with triangles. And that way, if you keep it all together, if you're going to deal with rectangles, you can make a rectangle object. Then you can have your length and the width. You can have your area function. You can have a perimeter function. You can have all you want in there, but it's all strictly connected. And that way, you don't have accidents such as calling the rectangle function to compute, or how about this one? This is a good mistake. If you have a square function to compute the area of a square, you just need one dimension, right? Because the square length and width are the same, right? So the only parameter for the square, would be something like this. So it'd be like int area and then an integer, and that integer would be basically the length or the width because they're the same. So the return would be basically x squared, right? So you could do that in C++ by saying x times x, okay? But suppose that somebody else wanted to create an area for the circle, as we said. How is that going to look? It's going to be identical, actually. At least in the parameters. Inside is going to be different, because here it's going to be like return x times 3.1415, like 91 or something, whatever pi is, But, suppose you coded your square function first in the global scope. Then I come into code and I try to code my area function in the global scope. I try to compile. I try to run because I'm calling this on the radius of something, and then I have this ambiguity error because like we were just talking about the function overloading thing, right? And then I'm like, oh, damn programmers, But then again, I'm doing the same bad problem, so it's more like I'm angry at them than at myself. So it doesn't make sense to have this at a global scope because you're sort of invading the space of other programmers per se. And so it makes sense that because this is related to rectangles, well, I guess one solution, but bad, would be just to say rec in front of it, call it rectangle or square, I guess in this case. But the better solution is, okay, this is the bucket for square stuff. We can have a length, we can have a single dimension because it's a square, we'll call it just length. And then we can have the area function in there. And that bucket is just for that. So when I'm dealing with squares, I can create an object of that bucket. When I'm dealing with circles, then I can deal with the other bucket. And so that's sort of the benefit of object-oriented programming. And so if you want a formal definition of classes and objects, then this is what I got for you. A class is a collection of a fixed number of components. Okay, so class is a collection of a fixed number of components. The big word here is components. What are these components? The components, you can think of them as members of a class. So a component is a member of a class. Okay? What kind of members can a class have? The two main members that a class could have are going to be some of the names are variable and function, but some people call them fields. And then methods, yeah. I've seen that name as well. They mean the same thing, variable and field, function and method. You can also just call it the data and the operations on the data. Okay? So, big definition, class is a collection of fixed components. What's a component? It's a member of a class. Well, what's a member? A member is either a variable or a function. What is a variable? Okay, now we're 135 level here. That's just basically some data that you can store. It doesn't have to be a built-in data type. It could be another class. You could have like a matryoshka of classes, which we'll talk about later on in the week. That's called aggregation or composition. Functions, on the other hand, are just the functions you saw above. But now they're being sort of kept inside the class. And you can think of this as a little bucket. And then, as I said, object is an instance of your class, basically. So are you guys still here? Everybody's being super quiet for like the last 40 minutes or something. So I want to make sure you guys are alive. The stream is alive. Okay, good. Yay. Okay, you guys are alive. Good, good. Let's see if there's any other definitions I want to throw in there. Nope, that's enough for the definition world. Hey, you guys are on here. Nice, cool. So that's good for the basics. So now let's go ahead and actually let's go to class, shall we? Now, intuitively, I want to do this rectangle thing, but I think that's the same example that I did a few days ago. So let me think of something else that's not a rectangle. You guys have any ideas or suggestions? What could be a cool thing that's not like a trigonometry figure to do? Let's do a house. No, the house is lame. Let's do what is a good thing to do? No, that's like shapes. I'm trying to get away from geometry because like I always do the geometry example. And you know, one of the things that I suggest for refreshing this is you can also watch that lecture when I talked about classes and struct in 135. So I'm trying to go with a different example. I think I'll go with let's go with the anime stuff. Yeah, they always say to go with the anime stuff. So let's go with anime, class anime. We'll come up with this as we go. Why not? Yeah, we're gonna do an example of a class. So let's do class anime. So I have no idea what we're coding. It'll just come. It's like art, you know. You just let it go. You feel it as you code it. So yeah. Okay. So we're making a class called anime. Okay. And so the first thing you should know is actually let's not even use the word class. Let's use the word struct. Let's take baby steps because you guys know structs. I hope you do. Okay. So with a struct, you can have variables and you can actually have functions. By the way, this is something that may come as a shock to you, I suppose. Not really. But the only difference between a struct that you learn in 135 and a class in 202 is how the members are declared, whether they're public or private. Now, that's a keyword that I'm going to come back to visit in a little bit, but that's the only difference. You can do all the stuff that function object-oriented programming idea with structs. The only reason that we have the word struct in C++ is more because of a C sort of backwards compatibility kind of thing. But we're going to use it now because that's what you're familiar with. So we're going to create an anime. So what does the anime have? They have characters, right? And I'm not much of an anime person, but the students like the anime, so I try to sympathize. So what features does an anime have? Like, let's create some characters. You guys tell me the character names that you want, and please don't go with like some obscure, like super hard name to spell out here. So give me some anime character names. We're making our own anime here. So give me some names, guys. Goku. Oh yeah, Dragon Ball Z. I actually know Dragon Ball Z. So yes, let's go with the Dragon Ball Z thing. So each anime is going to have. Okay, that's enough. Okay. So we're going to have our struct have a name. Oh, for character. So car name. We'll call it car name for character name. Okay? And we're going to say his name is Goku. Okay? Then we're going to create another one that is, if I remember my Dragon Ball Z, there is Vegeta? I don't know how to say that. And then sure, we're going to pull in Spongebob. Now this is kind of an issue here with the names, but we'll fix that in a second. It's not really an anime, but why not? Okay? So let's go ahead and call this the character name one. Well, that's lame names here. Let's call him the good guy. This is the bad guy. Although I don't think he was a bad guy. I think Freezer or Mr. Cell was the bad guy or something. And then this is the sidekick. Okay? So we got 3 strings and that's what they are, okay? And so this means that whenever we want to create an anime here, we want to instantiate an object of this class. We can say something like anime Dragon Ball Z. Okay? That creates an object of Dragon Ball Z. Now, notice that I use this sort of syntax. This is actually C++ 11. If you try to compile this with regular C++, which I actually don't have C++11 by default here, we switch over the function name of this. What time is it? We still got time. Then I get some warnings. It actually compiles, but I get warnings. If I want to get rid of those, then I can do 11, and now we're good. So this means that when I create an anime, it has 3 fields or 3 member variables. It has a good guy, a bad guy, and a sidekick. Okay, let's create another anime. Now this one, what are we doing? I guess we'll do SpongeBob, because I actually know that. I don't, or unless you guys can tell me, or you guys tell me a set of an anime of a good guy, a bad guy, and a sidekick. You guys do that. I will make 3 of them. I'll make one for SpongeBob. You guys make one for another one. Although that doesn't make sense to have SpongeBob here then. What would be a sidekick here? What was the name of the kid? The bald kid that had like a Dragon Ball thing on his forehead. In Dragon Ball Z. It was Goku and Hammond? Johan? It was like Johan or something. Oh, Krillin, yeah. Krillin. See, I watched it in Spanish, so the names might have changed a little bit. Oh, Gohan was a kid, actually, wasn't it? Gohan was a kid of Goku or something. I don't know. Yeah, I watched this stuff in Spanish when I was a kid, so like that actually makes it more abstract for me. But, and the translations were probably not good. But anyways, so, okay, now for SpongeBob, we're going to do the same thing. But in this case, how do we access the individual variables so that we can do this in main? We use the dot. The dot is known as a member access operator. Notice the name, member access operator. Accesses members. So that's why we're accessing the members of a struct or a class. So the good guy in SpongeBob is, of course, SpongeBob. I'm still waiting for you guys to give me the 3 combo for the next anime of the good guy, bad guy, and sidekick, and the anime name. So just post that as a one chat message. The first one to post it is the example that'll come here. So we got SpongeBob, and then SpongeBob's bad guy would be Plankton, right? I actually, believe it or not, I was watching SpongeBob like the other night. I saw like 2 new episodes. So that was interesting. I used to really like it. It came out when I was a kid. I think it's still coming out. And then the sidekick is Patrick. Start. Okay, so you got Luffy, Blackbeard, Zoro, One Piece. Is that a thing? Who's what in that one? I'll go with the Naruto thing, I guess. But then, which is which? I think Naruto's in there with the anime. It just sounds like it would be, but because I feel like I heard that on the internet. So then, here, let's just go with that because you made it easy. JJBA. Okay, we'll go with that. JJBA. I hope this isn't like some obscene, like obscene stuff. Good guy. Oh, well, I gotta change this. Dot good guy equals Jojo. JJBA dot bad guy equals Dio. And then these are not like super long names. Sidekick equals Speedwagon. Okay, there we go. So we created this anime class, right? So now, suppose that we wanted to have an operation on this, such as the most basic thing is we want to print out the details of our anime objects. So while one of the solutions that we can do, and we'll do it first and then translate it, is we're going to create a print function. That is basically, if we were to do it the old school way, we will need to pass in 3 strings. String A, string B, string C. Obviously pick better names. And then you could be like, there's no easy way to get the anime name because it's the variable name. And I don't remember if there's some nasty way that you could get the variable name. But we could fix that actually. Let's just add in a variable called name that stores the name of the anime. This one will leave, I guess the default will do the Dragon Ball Z as well, since we did that as a template. And then here, let's do this SpongeBob name equals SpongeBob SquarePants, I guess. And then this, I'm going to assume that's the name of the anime. JJBA. Okay, so we can say anime And then I guess we'll need one more string then. String D. And then it could be anime A. C out. And then good guy B. C out. Bad guy C. And then C out. And I need to put some line feeds in here as well. Sidekick D. One more actually. Okay, so let's go ahead and test if it works. Let's try to call print on the last one here. Man, we're getting kind of big here. The problem is now I gotta actually do like what I would essentially define as cancer, which is literally. Let me scroll down. I have to get this in the right order, which is not fun already when I have 4 variables. So which one goes first? I think good guy goes first. And then bad guy goes next. And then sidekick goes next. So you can see that this is just it's already starting to look nasty. Because we're doing it the other way, the old school way, right? So. Oh, it compiled. That's good. We run it and it works. Anime, JGVA, good guy, bad guy, and sidekick. I think we need some colons, but other than that, it's it works. It works, you know. It's pretty good. So this print function, though, you know, if I'm looking at print, you know, if I'm calling print over here, I'm like, yeah, I'm gonna call print. It's like, yeah, you gotta pass in a bunch of strings, and there's no documentation. Even if I had documentation, I have to be like, yeah, the first string is this, the second string is that, and yet again, this is only related to the anime printing. So it makes sense to put it in the anime bucket along with the other degenerate variables. So let's go ahead and do that. So we are going to go ahead and take this and insert it into our struct. Bam! We have now inserted it there. Okay? We can leave it out here actually still. But now we actually have even more advantage, because as we did it now, it isn't really doing much of a positive, you know, thing to this. So what the cool thing is about having an operation or a function inside of the bucket with the variables is that you don't need these parameters anymore if all you're trying to access is member variables, which are the variables in the bucket. All you gotta do is access them by name. As if, imagine that you are doing this in a global scope and these were global variables, which you should never do. You could think of it like that, because now I can actually refer to them just as if I was talking about variables that were in a global scope like this. I don't need, this is a function, but I don't need to pass in parameters here, and I can refer to the parameters inside the class by name without anything in front of them. And now, to call this, let's try calling it on Spongebob this time. We can do Spongebob.print. So just like I can refer to variables with the dot, oh, you can't see that, hold on. Spongebob.print. I can refer to the variables like this, bad guy, good guy. I can also just call print like this, put my parameters, and voila. This is kind of how when you're doing string size or things like that, or vector size, or vector pushback, that kind of thing. Ah, failed. We forgot some parentheses or things. Line 22. Oh, we have an extra rogue curly bracket. I don't know where that came from. Okay, now it's gone. Yeah, okay. And it worked. We got, as you can see, the anime is working just fine. We no longer need this one, actually. So now we can go ahead and just snap this one out of existence. And then we can replace this. Look at how big that is, right? We just replaced that one out of existence. I gotta look here now so I can see what's on the video. So instead of looking here, that way I don't not show you stuff. And we can do jjva.print. I hope that by showing you this by example, as you can see, you get the same output. How much nicer it is for me not to have to pass any parameters. I know some of you in 135 hated passing parameters. Now, I'm not saying you shouldn't learn how to do it because it's important. Sometimes you need it anyways. But At least you save a lot of that parameter passing, because now you're dealing with the variables inside, so you don't need to pass any parameters. And as you can see, I'm declaring the function inside of the struct. That also means that if I try to call this function print outside because I have the other one commented out, I cannot. There is no function print anymore. If I try to do something like that, it says it doesn't exist, because it doesn't. Another thing that I see a lot of people make a mistake on, I cannot do this. I can't do something like anime.print. We will talk about static variables and things like that, but for now you don't know what that is. So all I want you to know is that you cannot do this. Why? Because let's understand what is happening here. When I'm calling print, I am calling it on a specific object. That specific object has specific data in the member variables. All the objects have the same functions. Yes, they all have a print function in there. In fact, to save memory, the computer probably only has one copy of the print function. But each object is its own bucket with its own variables. And so when I say JJBA print, I am calling the JJBA bucket that has the name, good guy, bad guy, and sidekick variables in it, which contain their own unique data, which is that. That's that bucket. When I call the Spongebob bucket, it has its own set of name, good guy, bad guy, and sidekick, which has its own data in it, which is basically that. And same with the Dragon Ball Z. If I call anime print, this is the name of the class. That's like trying, if my buckets were from Home Depot and they're like, the brand is, or let's use Dome Depot, because Home Depot, I don't want to sponsor anybody. Dome Depot. They're from Dome Depot, okay? That's the brand of the bucket. That doesn't mean I know what's in the bucket. If I say this is my Dragon Ball Z bucket, it's a Dome Depot bucket that is dedicated to Dragon Ball Z. On the other hand, if I just say print what's in the Dome Depot, it doesn't make sense because there's no specific instance of it. So I hope that this makes sense as to why it doesn't make sense that to do this line of code. Or furthermore, suppose that I try to do anime.name and assign that to something like hi. You should be asking yourself, which of the buckets is this hi going in? Which of the names? Because SpongeBob has a name, JGB has a name, Dragon Ball Z has a name, but anime is just the blueprint. It's not a specific object, so it doesn't have a name. Okay? So that is why the functions and objects can only be called, the functions and variables can only be called on a specific object, not on the blueprint. There is what is known as a static function, which kind of violates this rule, but again, we're not there yet, so I don't want you to think about that. Does that make sense? And I say this because, this is something that I actually didn't emphasize when I was going over this in 135, and I had some people have a hard time understanding that concept. So I thought I would actually kind of emphasize on it this time around, learn from my mistakes kind of thing. So I want to make sure you guys get that why, understand why these two lines of code are wrong, why they don't make sense. Because you should be like, whose name are we talking about? Whose print are we talking about? Because the print is referring to the variables that bucket has. And if I call it on this, it doesn't know if this is the SpongeBob or the Dragon Ball Z or the JJBA. Okay? So, yes, I thought I'd really make a point out of that. Okay? So, we have a function now, and we have variables. Let's throw in another function. Let's go ahead and do a function for speaking. Let's say that we want a function that says this person speaks. Okay? So we're going to call it speak. And it does take a... well, we could do one of the things. We could pass in the parameter of who we want to speak. Or better yet, let's make a function called good guy speak. And then we're going to pass in what they're supposed to say. Okay? And so now, we can say see out good guy, and then colon, and then str. And so now, if we call this function and say JJBA dot, who do we want to speak? The good guy, I guess. good guy. Or we can, never mind, we just wouldn't call the good guy function. Good guy speak dot or parentheses and then let's see, konnichiwa. I'm assuming this is some Japanese thing. Konnichiwa. Okay, I don't know if that's how you spell that. Okay. So now, you know, suppose that we add some line feeds to this to make it nicer, and also maybe add a line feed here. What am I doing? It's because I have the cursor there that's just throwing me off. There we go. So, Jojo konnichiwa. And there you go. Voila. It works. And so, now we have a function that speaks. Now, we could have a generic function that just calls speak, but that would require a parameter of who you're talking about. You could use flags like 1 for good guy, 2 for bad guy, and so on. But that's not very useful in that sense. But it's okay to have a function called like this because you know you have to have a good guy in this function because it's inside the bucket. Now, another thing. This is kind of becoming a little bit big. So is there a way to take out the code from the functions to kind of keep this nice and thin? Because this is a blueprint. And the answer is yes. However, you don't just do this. Don't just do that. That's bad. You leave the function prototype here. However, you have to add a little bit of code here to get this working. And that code is going to be the scope resolution operator. The scope resolution operator is known as the 2 colons. And what it says is where to look in the code for such a definition. And so what I need to do is I need to put the class name, and here it is the class name, not an object name, and then colon, which is the scope resolution operator. Here, I'll write it down here so you can see, in case you can't understand or something. Scope resolution operator. And then, actually, you need to put the void in front. My bad. So yeah, put the return type first, put the class that it belongs to, scope resolution operator, and then the function name. And you can actually, potentially, you can initialize variables like this, but I wouldn't recommend it. It only actually will work for static variables, not for object variables, because then it's like, whose variable are you initializing? So we'll have to talk about static sometime soon. Otherwise, I keep mentioning static, and you're like, huh? So yeah. But yeah, so doing this method, you can take the function out of the class so that you can, strictly for your visual pleasure, in the sense that, you know, this looks much nicer. So we can do that actually with the print function as well. Anime. And then do it like that. And as you can see, this looks much nicer. As a developer, if you want to see what functionality this class or struct brings me, all I got to do is look at the variables it has and the function names. And hopefully that's enough for me to kind of guess. And if I need more details, I can always, if you're doing a proper ID, you can click on this. Oh no, here, oh, there we go. It actually tells you, go to definition. So yeah, and then you can actually see it. And also it'll give you documentation. So as you can see here, if I highlight good guy speaks, it says scope resolution operator because it's a document I have here and it assumes this is documentation. So like, this function makes the good guy speak in our anime. And so now, if I highlight that, you can see the documentation. I'm pointing at it, but you can't see that. You see that? So this is much nicer, as you can see. Okay. So now let's switch over to the word class, since it's still using struct here. So let's just throw it in. Class. Now we're talking C++. However, oh, it compiled. Why did it compile? Huh. That's strange. Oh, I didn't save, that's why. I was expecting to see an error. So. You know, it's like opposite of what you want. You don't want errors to show up. In this case, I was hoping for an error. So I was like, what? So yes, we get a lot of errors. And you're like, oh, you lied. Class and struct are not the same. Yes, they are. With one exception, I said. And that's the private and public situation, which is exactly what the errors are telling us. The errors are saying that anime name is private and good guy is private and all these things are private. So let me shut up the compiler with one keyword. which is the public keyword. And now you will see that it works just fine. Yay. However, what is a public keyword? So that's the next thing that we need to talk about. Okay. So back to the iPad for that. So we've talked about the bucket. You know, big bucket, big beautiful bucket. However, the bucket can serve other purposes than just putting data together. It can also make your code a little bit, it can make your life a lot easier when you're coding. And by that I'm saying a lot easier for other people not to break your own code or your code. Because like, here's the thing. You write a global function that computes the area and it works fine. You know, we wrote it up here. Where is it? Yeah. However, you know, if I feed it I guess in this case it's okay, but suppose that I was computing, what would be a good example? Suppose I had a function to compute the division of something, and I fed it a value of 0. You can see how that can cause problems, right? Division by 0, that kind of thing. And so, what can you do? Well, if you're a programmer, you can sanitize your input. You know, the first thing you do in your function is you are going to check the parameters, see if there's any values that are bad, such as zeros, and if they are, then you can stop the function and throw an exception out. You don't know what that is, so for now you can just see out saying error division by 0, and you just return something, just to kind of move on with your life per se, right? That's your standard debugging and standard error catching as you know so far. Okay. So that can continue, not a problem, but sometimes it's also useful to have some sort of error checking and limiting what kind of values can be going inside our bucket, okay? And so one of the things that you can use objects for, and classes in general, is to control the kind of data that gets fed in your functions before the functions themselves even get called. And so, suppose, you know, that, suppose that you didn't want, so, you know, you have your anime class, which has a good guy, a bad guy, and a sidekick. And suppose that you're trying to make this PG friendly. And so, when people create objects of the anime class, you want to avoid them from putting in bad words, okay? So you don't want the main names, the good guy's character to be like a bad word. And let's pick a bad word to be potato, okay? So we don't want the character to have any part of the name include the word potato because it's an insult to potatoes, okay? So, can we limit the names that go in there to avoid potato being part of a name? Now, why would you want to do that at the coding level? Well, I guess to avoid troll coders would be one of them, but more importantly, to actually protect yourself from errors and others from errors. Because, you know, potato, insult, whatever, you know, people can deal with an insult, I suppose. But something like a value of 0 in a division can crash a program. So you can avoid errors by limiting the user from creating variables that are invalid. Okay, so in our example, if we wanted to do that, we can give him age to the good guy, you know, and we can say that we only accept positive numbers for the age. Why? Because if I go and try to create an object of your anime class and I give it a negative age, then I want an error to happen at compile time to prevent errors from sneaking away in development. And so this brings the idea of a private versus a public variable. A private variable is a variable, they're both variables inside your bucket. However, private variables are variables that can only be modified from within the bucket. So you got your operations, you know, I'll make them with little gears. And these are your functions, right? These are your methods. And then you got your variables. However, some variables can have a little lock on them. So here, I'm actually be a good visual representation. And some of them, you know, have the lock open. Here's the difference. The ones with the lock are private. They can only be modified by functions inside of the class or struct. So in our case, we have a couple of functions so far. We have print and we have good guy. Those are the only two functions that can modify the contents of that variable. If I try to modify it from outside the class, like I'm actually doing here, because what I'm doing is I'm trying to set the name from outside, you know, I could put in potato in here and get away with it. It wouldn't stop me because that is a public variable, which means anybody who has access to the object can access the variables in the object, right? Because the object itself is JJBA or Spongebob or DBZ, right? Dragon Ball Z. If I have access to that object in that scope, I can use the member access operator, and then I can access the individual member variables. If they're public, I can change them all I want. If they're private, I will get that error that you so clearly saw, I suppose. Basically saying, anime sidekick is private because I did string sidekick equal Krillin. That was the thing. Oh, I guess it was. For example, here, this one. So SpongeBob.sidekick Patrick star. Okay, so it's saying that name is private within that context, and it gives you the declaration. Okay, so do you kind of get an idea as to the why that is useful? It's again, it's to protect yourself from giving it potentially bad code. Because here's the thing: you can write code and then you can do a lot of error checking, but you can save a lot of the extra and unnecessary error checking code if you don't let them have bad values at the variable level. And you can do that doing basically a private variable. What could be other usages of private variables? Perhaps you have a counter inside of your class that deals with certain operations, like how many times certain functions get called. These are variables that are internal for the class. The developer has no usage or no purpose for modifying these variables. So there's no reason to give him access to them because it's sort of like preventing accidents from happening. Think about a car. This is actually a good example. Maybe for even like a Tesla or something. Your cars, you got a steering wheel, you turn it this way, the car turns, right? You don't have in the console of your car like internal tweaks to the computer so that you can modify things such as like brake distance or the sensors in your system, like like automatic brakes. If you have a car in front of you and it stops, some cars like slow down beforehand, like collision assistance or whatever they're called. You don't have as an end user a way to modify that. Why? Because let's be honest, the people that made the car think you're not smart enough to deal with that. Because if you try to modify that, you're gonna break the system and you're gonna end up crashing. You might be like, oh, let me tweak this to increase the speed of my car or something. Next thing you know, you broke the system, you crash. Exact same thing with the computer. We basically are like, yo, I don't trust my fellow developer to be smart enough to use my code, so I'm going to limit him on what he can and cannot do. And that's the truth. That's the hard and sad truth. We don't trust other developers per se, So basically, things you wish to keep constant or private? No, not exactly that. It can be a variable. It doesn't have to be a constant. Constants, I'm kind of glad that you brought up the keyword constant, because think about what constants do in 135 level. Like, they tell you that constants are memory locations that cannot be modified after they are declared, right? This is a little bit different than the literal, which isn't a memory location necessarily, right? And so a constant, the whole purpose of creating a constant is that once you declare it, you don't accidentally modify it. But technically, I could go in any code that has a const, switch it to a normal variable, and as long as I don't modify it by accident, my code will work just fine. So I could make a pi, So if you remember, you constant int pi, right? I could do something like this, 3.14. And the idea behind the const is that I don't actually go in there and accidentally say something like pi equals 4 and then just break pi, right? But I could also just do this, and if I don't modify it, it's fine. So the same reason why we have const in CWS 135 is the same reason that we have these things such as private and public. The idea is to control what you can and cannot change. So it's kind of like that, but in this case, we're not limiting, because with const, nobody can change it. Not even you can change it. With a private variable, you can change it, and by you, I'm saying your functions inside of your bucket can change it. So for example, let's make a counter that says chat. So every time that somebody talks, and again, for now, we're gonna put the public here. Let's say that, is there a typo somewhere? Make sure this compiles. Yep, there's a typo. Oh, why did I put it here? That's not where I meant to put it. This code is getting too big. Oh, it's already public. Never mind. So I think we're actually okay. Okay, so suppose that I want to create another variable called counter. Maybe not counter, just that's a bad name. Lines, int lines, and that's kind of bad too. But okay, we'll go. And then we'll initialize it as 0. There are other ways to initialize them, but we haven't talked about them yet. Okay. So, however, every time that we say good guy speaks, my lines gets increased, and by that I'm saying how many lines in the script of the anime does the good guy speak, right? So when we call it, you know, oh, I know what I can put in here. The ayaya thing that we were talking about in Discord. So, you know, we spam this a couple of times, and so now we can go ahead and see out jgba.lines. Okay, and so now that should be about 5. Oh, 8. Damn, I copied and pasted it that many times. Okay, sure, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh wow, that is 8 times. Okay, cool. Here, let's so you can see them better. There you go. You can see that there's 6. Oh, 8 because of this one. Yeah. Okay. So this is good because it keeps track of this, and it might be useful for us. But somebody by accident, not intentionally to be honest, but accidentally, could actually put ++ manually there. Or worse yet, they could because they might be like, oh, the lines must be for counting people, how many times they speak, but maybe we gotta do it ourselves. So they increase it, and now they count us off by 1. Or worse yet, they might just flat out change it, you know. Most of the time, not intentionally, but that's kind of the thing. So it's a safekeeping mechanism. Is it truly a secure system? Absolutely not. When we talk about pointers and we talk about reinterpret cast and some nasty stuff, I will show you how to change private variables. It's actually quite simple to do. You even have an assignment called Crack the Ball, where you change private variables. And it's actually, people said it was their favorite assignment when I taught 202 last time, so I kept it. So I think you like it. So yes, essentially yes. It is really to prevent you from shooting yourself in the foot. I agree with that. It's, in a way, it's a little bit similar to const in the sense that it's protecting you from doing things you don't want to do. But yeah, and it's very commonly used. So anyways, public and private. Public variables you can change, private you cannot. So in this case, what if we want to make the lines variable private? Everything else can stay public for now, but what if we want to do that? Okay, all we got to do is let's go ahead and move the lines to the bottom just so that we can make it easier. Although technically we just have to put it at the top, that would work too. Lowercase, not uppercase. And so now I will get that error about being private. See, it's private. So now I can't change it. I can print it, but guess what? No, I cannot, because that's going to cause problems too. So now you're like, wait a second, you know, okay, I get it. You don't want me to change the variable, but I can't even see it. I can't even print it because it's private, right? So this creates another issue. Suppose that you wanted to have a variable that you want to keep private because you want to avoid people from messing with it, but you still want to be able to be seen. You know, you still want it to be visible to other people. For that, you're going to need what's known as a getter and a setter, and we will talk about that next time. But you can think of that as the messengers in your bucket. Now change the bucket idea to a castle. And so the people that can access stuff in here and back out are going to be the messengers, and those are going to be your getters and setters. And those are the jobs of them are to either access data or potentially change private variables using a function. Why using a function instead of directly with a variable change? Because the function can do error checking and that kind of thing. So we shall talk about that next time, because I think officially the class ends at 6:50 or 55. I don't know. I think it's 55. Might be 50. It doesn't quite matter. I'll check it for the next time. 55. Okay, so I guess we do have 5 minutes then. Cool. All right, so I don't feel as pressured. But yeah, so essentially your getters and setters are going to be your messengers, but they can sanitize things. You know, they can be like FedEx, and they're going to scan the package before putting it in the castle to make sure there's no bombs in there per se. And so that's going to be your setters are going to set private variables. The getters are going to let you access private variables where you can see them, but you can't change them. And that will be useful for the lines thing, because we want to know how many lines the good guy speaks. We just want to allow him to change it. So it's like, you want to know? Give me a second. Okay, I checked it. He speaks 8 times. Can I change that? No, you can't. This is read-only kind of thing. So that is what we'll basically be looking at tomorrow. But for now, at least you kind of got the idea that you can store more than just variables in your classes or structs. You can store functions. And like I said, the difference between public and private, we'll revisit it next time, is whether by default it's set to something. Notice when I was using struct, I never had to put the private keyword or the public keyword in there. But when I switched to class, I had to put the public keyword because by default it's private. So we'll revisit that. Don't worry too much about it. But for now, I guess for the last 4 minutes, does anybody have any questions on the assignment? And if not, you can post it on Discord too. Dog is back. Hey, dog. Oh, she's trying to choke me. Thank you for your class. Yeah, you're welcome. Oh, there she goes. She likes going back there. Oh, shoot. Ah, she's pulling the... There we go, the cable. Can you go over how to use a find function for strings? Well, I can go over it, but you can't use it. You can't use find, and you can't use... what's the other one you can't use? Sort. You can't find and you can't sort. You got to write your own find and sort function, because I wanted to refresh that. But normally, if you could use it, it's quite straightforward. You just go ahead and you know, string str, blah blah blah. What you do is you just do str.find, and you put the string you're looking for. So if you're looking for like a maybe FA, like that, and what it will return to you is the index location of where that starts if there is a match. Otherwise, it'll return to you 0 or -1. I think -1. Oh, we still have the errors from this thing here. Somewhere in here is the find part. Oh, 5. Yeah, see, it's a 5 right there. I know it's tiny, but it's the index of the thing. So 0, 1, 2, 3, 4, 5. So that's how strfind works, but you can't use it. So feels bad, man. I'm glad that you brought it up, though. We're trying not to be jealous of your dog. Oh, thank you. I'm still having trouble with the struct pushback thing. Do I need to create a struct of tweets called tweet and then pass that into... Yes, so you need to create... So what you need to do, if you look back at the... And you guys don't have to stay, by the way, if you don't have questions. You guys can head out. You know, I'll stay to answer some questions, and then I'll end the stream. I won't teach anything new. If you look back at the review that we did, you know, in here we were using an integer. But if you want to, if you want to pass something other than an integer to a struct, you have to declare a struct of that type. That's what you have to do. So you need to do something like, you know, if you have a struct, actually, might be better for us to create a struct of animes. If you create a struct of animes, you know, it would be something like vector, and then anime, and then, you know, anime list. And then you need to create a struct with all the information in it. So like, for example, create an anime like JJBA, fill it up with everything. And then after that, you can do anime list dot pushback. Sorry. Yeah, no anime list. No, that is fine. Why is it? Oh, I see why. It's because we gotta include the library. It's, when the color coding doesn't work, it's a sign that there's an error, and that was the error. So anime list dot pushback, and then you push in back an individual struct. Individual struct. So like JJBA. Okay? Now you could put this in a loop, and every time you could change the struct that you're pushing back, but so that, like, for example, you create a temporary struct, you fill it up with the current tweet, you push that tweet, go to the top of the loop, create another temporary struct, fill it up, and then push it back. So you're going in this circle like that. But the thing that you messed up in, or if assuming you're the person that you asked in Discord, is you were trying to do something like anime list dot like bad guy or something. I think it was something like that. You can't do that. You can only push back the entire struct. You can't push pieces of the struct. You push the whole thing, or you don't push anything. So that's why you gotta create a, you know, if you were running this in a loop, you know, go ahead and create a temporary one. So like anime temp, fill it up, you know, bad guy equals blah, the other one, fill it all up with that, and then do the pushback, and then put this all in a little for loop that runs for the number of tweets you have, or cn.eof, whatever. Yep, I did all of that, and when I do the tweet pushback, no, but see, you're doing STR. But see, it's probably not in the string. It has to be a tweet. You're pushing back a tweet. You can't push a string. Yes, there you go. The last message you wrote is good. Yes. So create a temporary struct like this. Fill the temporary struct with all this stuff. So here, like, suppose we're doing this guy. You know. Fill it up with everything, you know, and then push it back. And then after you push it back, you can't even, if you want to modify it after you push it back, which you really shouldn't, if you design it correctly, then you can just use your regular indexing. So you can do like anime list 1, and then you can see the things. But only after you push the entire thing. Don't try to do it this way that I'm showing you. Don't try to do it any other way, otherwise you'll get confused and things will explode. If you can't use, fine. Are there any functions we can't use? No, you can pretty much use about everything. It's just I didn't want you guys to, I wanted you guys to practice finding data in text. So you have to code your own find function, which is just a for loop and checking each character into the array of a string. So that shouldn't be too bad. And then for the sort one, you'll have to refresh your mind on bubble sort or selection sort, or just, I mean, you're only finding like the top 10 tweets. So it's kind of like my solution uses selection sort, but you can use just about anything for that. So yes, you can't use sort and find. Other than that, you can use size, you can use to lower, to upper, to string, all those things is fine. It's just I want you to practice those. So, okay. Don't think that there's any more questions. But anyways, thanks for watching, guys. I shall see you tomorrow at 5 p.m. I always start the lecture 5 minutes before. Not the lecture, but the countdown timer, so you can connect, and also I can verify that the internet is working. Could you further clarify get source and set source? So yeah, so if you look at the tweets, and I might be able to pull up the tweets here. Maybe. Give me a second. This one. Let's look at the Elon Musk tweets. The tweets, the first line is sort of the labels, because this can actually work in a CSV file. And then the first thing you see is some weird thing that says http twitter.com download iPhone. And then you see the tweet until the next comma. And then you see what I guess the retweet count, or the created at, then retweet, then retweet count, favorite count, and then the ID. Oh, whether it's a retweet, which is pretty much false for just about everything, and then the ID. Here, and you could see the part that I was talking about though. So basically, this part here that I'm highlighting is the source. The first item before the comma is the source. In this, they're all iPhones, but for some of them are Androids. What the get source and set source did for me is I didn't like this weird URL-ish thingy. So what I did is, if I detected that this was this exact thing, twitter.com/iPhone or whatever, I replaced that with the word iPhone. Easy way, you can just set it as a string. I wanted it fancy, I used an enum. And for an enum, it's basically converting into an integer. But then you gotta convert it back to a string if you wanna print it out. So that's why there's a get and set source. You don't have to do that. You can just convert it manually by hand to strings. But what I'm just doing is I'm simplifying the sources. And I'm also using other for the other sources. Like they're not iPhone or Android. I think there's like more than 5, but I only used 5. That one is more visible in the Trump tweets, I think. So these are all iPhone. But you can see this is using different syntax. It's on Twitter for iPhone. You see that? Now, at some point, this guy changed from Android to iPhone. Because apparently that's how they found out if he was writing the tweets or his aides. So, if you go long enough in this, you eventually see that he starts posting mix and match between Android and iPhone. And like the NASA ones go with a completely different system as well. You don't technically. You just have to have a way of converting it. It will take too long for me to go down. Twitter for iPhone. It will change eventually. Some of these have other than iPhones. Maybe if I go to tail. Yeah, look at this one. Twitter web client. So this one, I guess, was from the actual website. And so, yeah, so see that. His first ever tweet was from the website. I guess before they used iPhones, back in 2008. We won't lose points if we don't use it. Not as long as the code works. What you cannot do is you cannot... So, you can do more functions, but if you do less, that is because you're doing still the code not in main. I don't like you to write code in main. Main should be kept only for function calls and very minimal code. So if you have some other way of converting this thing into the more clean version that I have, where it doesn't use the URL, HTTP, iPhone thing, you still gotta make some kind of function that does it. I don't want you to put it in main. That's the only sort of limitation. But yes, you don't have to use the 2 functions. So, yes. Cool. All right, then. Anything else? Speak now or hold to your peace for the next 24 hours. Actually, no, you can just go on Discord. What does these say? I'm actually... Wow. Okay. I might have become dumber for a second reading that. Do we output the top line in main, or can we use it in set get source? You can probably do it in either one. That's okay. I can let me check my solution, I suppose. Here, let me open it on a different window, so you can't. I don't want to just pop up with my solution for the stream. Open. Oh snap! But that's still my. Okay, hold on a second. Then let me go like this. Okay. Where's my main? My main. My main, the first thing I do is an error check in the case they give an invalid file. Like, they don't give a file actually. And my main still has the prompts like enter a phrase, enter phrase, enter phrase. But it doesn't have anything else other than the function calls. I call this one Freedom Printer, but you guys have a different name for it. I don't know why I call it that. And then it has the total tweets read and thanks for playing actually in main. But yeah, my main fits in the screen. So like it's maybe 20 lines of code or something. Goes from line 76 to line 41. That's 30 lines of code. So, yep. All right, guys. Like I said, if you have more questions, then hit me up on Discord. I am available pretty much all day, unless I go to sleep. Like yesterday, I did go to sleep early, and then I woke up at like 1 a.m. I also use Livestream and see in the file. You have to see in the file instead of retweets. You can't do it in main because I want to make sure that you know how to pass parameters like that, which is what I did today with the Livestream parameter thing. Yes, but then in your loop, you want to replace it before you read it in, you know, to something that is closer to what I have in my output. Like I said, I think I simplify some of the terms. Like I use the word Android instead of built for Android, or I use the word iPhone instead of just like Twitter for iPhone. No, the way it works is when you get for 4,400 points or whatever that is, then you have the ability to redeem, and then when you redeem, it'll actually tell me here. Like a bunch of people today redeemed like the hydrate and whatnot, but that's useless. That is not really gonna get you anything. The only one that gets you stuff is if you redeem the extra credit one. So you want to save your points for that, unless you're feeling high roller and want to use them in anything else. So once you get to that, then yes, you can DM me. Cool. All right then. I think this time we're good. I don't know. I don't see anything else coming in on chat. Cool. All right then. I shall see you guys tomorrow then. I will be uploading the copy of this to YouTube. It should be up sometime in the night. I'm gonna go eat first, and then I'll go upload it. So 1 or 2 a.m. it'll be posted. So yeah. So for the X the function, I don't know what that means. Well, no, I gave you what's known as a function prototype. You gotta put in the identifiers, yes. That's just a prototype, you know, like you can call the variable. I didn't want to be like, okay, you gotta call your variable A and B. You can choose your own variable names. I just said these are the parameters that you want to put in there. And if you're passing by reference or a value, you know, it's a function prototype, what I gave you. You still gotta put the function body and then you put the identifiers. Otherwise the code won't compile. So that's why I gave it to you like that. So I'm saying you need an OSStream variable, but you can call it out or potato, you know, A or B, you know. Do meaningful variable names though. I think that's in the rubric that you might lose points if you don't. So, you know, comment your variables and give them meaningful names like out. That's actually a good one for that one actually. So yes. That doesn't apply for every single assignment. There may be some assignments where I may allow people to sacrifice their points to give out skeleton code, but I will bring it up if it comes up. In the meantime, I wouldn't waste your points on that because it will not do anything. I just set up a bunch of things so that I have it ready to go. So don't get scammed into losing your points in other unnecessary things. Okay, I think this time we're good. I mean, I'm like waiting to see. There's a slight delay sometimes between Twitch and the text chat. You can probably see it when you see your chat appearing versus when like you type it. So that's why I try to wait a little bit to see if more questions come up. Yeah, that's what the other person asked. So you will open the file inside of the read tweets function. And then for the writing, you don't open any files in main. You pass in the argument with the ARGB you're passing into the read tweets function so that you can read it in from there. You don't open anything in main because I want you to practice passing in that Livestream because that actually will come back to haunt you if you don't know it when we talk about operator overloading. So that's why I'm making you do it. Why are you guys not writing all these questions on Discord? Like, I've been here all day, and I had like one person ask for help. And I was like, I guess you guys all get it. So you can ask on Discord, like, you know, I'll help. I'm open to questions. By the way, tomorrow the TA does have office hours before class. You know, so like, if you want like a one-on-one help, which might be pretty useful, definitely, you know, hit the TA from 2:30 to up to class start time, 5 p.m. The TA will be on Discord in the voice channel. You guys can hop in there. He can give you one-on-one help. You can share your screen. He can look at code. I mean, don't abuse the TA, but definitely can be useful in those scenarios. And I would definitely use it. If you're really stuck in the assignment, that might be, frankly, the best thing to do. So, like, he gets paid to just sit there, and he's probably bored. So, you know, talk to him. Be friendly with him. And Padme is fine. Padme is sleeping now. She's sleeping behind again. I was kind of happy she left for a while, but now she's made me hot again. Sweaty. So, yeah, no, don't read it in test source, by the way. But yeah. Okay, cool. I shall go eat then, because I'm starving. But I have my phone even when I'm eating, so just post questions on Discord and I'll type the answers. Otherwise, I shall see you guys, like I said, in less than 24 hours, in 22 hours from now, actually. So, have a good night, everybody.